So, I want to talk about a population mean for a second. Pennies minted after 1982 are made from 97.5% zinc and 2.5% copper. The following data represents the weight of 17 randomly selected pennies minted after 1982. So treat the data as a simple random sample. Estimate the population mean weight of pennies minted after 1982. Okay, so can I find the mean of this? Yes. Do I know the true population mean? No, but my best guess would be to find this average and hope that it's close, right? How do you find the mean?
Add them all up and divide by the number.
Okay, so let's add them all up and double check our numbers. Also, I am missing a calculator. Please search for it, book bags, lockers, classrooms. Find that for me, please. Okay, I got it. That adds up to 41.89. Divide by the 17 pennies. And so I get a mean of about 2.464 grams. Okay, so that's my estimate for the population. If I picked a different 17 pennies, do you think I would get the same thing again? No, so kind of like we talked about yesterday. Every sample is probably going to be a little bit different. We can find the probability of getting a certain thing. But if I'm trying to just estimate the true mean, we would have to have a confidence interval because a different sample will give us a different estimate. So, the calculation for this is a little bit different. It switches to using a t-distribution instead of the z's. So everything we've done so far has been with z's, and we've been dealing with normal populations. The reason we're switching to this t is because if my sample is 17, is that enough to be normal? No, so that's why we kind of start going this route. So we use t's when we're talking about the confidence intervals around x bar. But just like we talked about yesterday, it's all on the formula sheet, and we're mostly going to focus on doing this on the calculator, so it won't change a whole lot for us. Okay. The thing about a t-distribution, when we read this table, is the degrees of freedom. It's always one less than the sample size. So if my sample is 17, it has 16 degrees of freedom. Okay, when we read the table for t that I'm going to show you in a second, it asks for degrees of freedom. That's one of the things on the table. So we'll have to be able to find that. So it's always n minus 1. X bar is our sample mean, mu, population mean, S, sample standard deviation. So the properties, it depends on the number of degrees of freedom. So it does depend on our sample size. But it is kind of like the z in that it's centered around 0. So the middle is 0. We can be above and below, half on each side. The difference from the normal distribution is it's less in the center and more on the tails. So it's a little more spread out than that. When n gets bigger, it looks more and more normal. So this blue line is the normal curve. Then we have the t when n is 15, t when n is 5. So we can see when n's getting bigger, it's approaching normal. And we know if it's 30 or more, it would actually be considered normal. Notation, just like yesterday, we were using z alpha. So we have t alpha notation. The t is just saying we're talking about the t distribution. Alpha is still area to the right. So that notation didn't change, just a different variable. All right, so first we're going to talk about how to read this. If I want the t value, such that the area under the t distribution to the right of the t is 0.2. So t looks kind of like a normal one. Area to the right, so this is 0.2. Assuming 10 degrees of freedom. So in other words, find t at 0.20 with 10 degrees of freedom. So let's go to our formula sheet. And if you flip to the back of the normal table, so this is table 7. It has the t distribution. It's kind of backwards from the normal. Normal, when you look at that table, it does give you area to the left. If you look at the picture at the top, this one is giving us area to the right in the table. So I don't know why they're set up differently. That's just what they do. Across the top, we have our probabilities. You'll notice we don't have all of them on here, so this table is a little bit limiting. But I do have 0.2. And then down the side, we have the degrees of freedom. So we have 10 degrees of freedom and 0.2. So I go down to 10, over to 0.2. And that gives us our t, which is 0.879. Did everybody find that? So this is just set up kind of the opposite of the normal table. The probability is that old number across the top. The number inside our table is our t. So it's set up a little bit differently. I want you guys to try one and make sure you can read it before I give you the answer. So read this one, see if you can find that value. So we want area to the right to be 0.1. So we're doing t of 0.1 with 15 degrees of freedom. So you go to the 0.1 down to 15, and what'd you guys get?
1.24.
Did everyone find that? Okay. So the confidence interval for this, the requirements, I'm not going to focus on the criteria too much with this. We have to have a simple random sample, less than 5%, so they're independent. The population would need to be normal, or we would have to have a very big sample. But we're not going to focus on the criteria too much. We just want to talk about how to set up that confidence interval. So if we're doing this, we have the formulas for upper and lower bound. If you look on your formula sheet, it does list them together with a plus and minus in between. So yesterday, it was all centered around p hat. This one is centered around the mean. So it's x bar plus your error and x bar minus your error. Okay, so the error is this t alpha over 2 times s over the square root of n. But same thing, it's centered around x bar. We're just getting a window of values. On the calculator, this one will be under stat tests. And if you go down, it is number 8, the t interval. So yesterday we were doing A, the 1 proportion z test interval. Today it's number 8, the t interval. So let's look at one. We'll walk through doing it by hand just so you can see it, but then we'll kind of focus on using the calculator. So going back to some data. This data reports miles per gallon of a 2011 Ford Focus for 16 different owners. Treat it as a simple random sample, constructing 95% confidence interval for the mean miles per gallon. So if we were going to do this by hand, we have to have x bar and s. Sometimes that will be given to us in the problem, but was it here? No. So do you remember how we got that?
You're finding x bar by
first we need to go to stat edit. So we're going way back. Stat edit, and you want to enter all of these in your L1. Get everything put in L1? And then remember, if you go to stat, calculate one variable statistics. Tells me my X bar is 36.8. S is 2.9171.
Is S our sample standard deviation?
Yes. And we're using S, not sigma, because we don't have the whole population. It's a sample. Stat, calculate one variable statistics. Okay. If you're getting error, it's because under your frequency list, you have something listed. Just delete that out. So it should be list L1, and there should not be anything listed under frequency list. Is anyone else the same dimension mismatched?
That's a silly error.
I know. Okay. To do it by hand, we need these things. We also need our n, which was how many? 16. And we're going to need, if you look back at our formula, T alpha over 2. All right. We want a 95% confidence interval, right? So 95% is in the middle. So that leaves 5% left, but split over the two ends, right? So this area to the right is 0.025 because it's only 2.5%. Your degrees of freedom is n minus 1. So I have 15 degrees of freedom. So I'm looking at my formula sheet. We're on row 15. And the area to my right is 0.025. So row 15, the probability across the top is 0.025. And the t value is 2. Did everybody find that? So our formula, if you're looking on your formula sheet, it tells you x bar plus or minus t alpha over 2 times s over the square root of n. So x bar is 36.8 plus or minus t alpha over 2 is 2.131 times s 2.9171 over the square root of 16. Type in the minus first because we want our small value first.
This is 4 different pictures.
Yeah, that'd be fine. If you get the first one, you can do second enter and just change it to a plus for the second.
This is we're 100% sure.
This is, we are 95% sure the value falls between these. So I'm 95% sure the true mean miles per gallon is between 35.2459 and 38.3541.
He'll never ask for a hard drive.
It's a big impossible. Okay. Did everyone get that to work? So let's talk about if we were doing this strictly on the calculator. I hope, did I give you guys a blank slide after this?
Yes.
Okay, so we should have a little extra space to work.
Tall rectangle for some reason.
Uh-oh. On your calculator, you are going to go to stat, test, number 8. Stat, test number 8. Okay. Now, you notice at the top, it has a question. Input or is data or stats? Data is when I gave you all these original values and we entered them in L1. Stats would be if I gave the problem and just said the mean is this and the standard deviation is that. So I gave you these original points, so we want to keep it on data. And then it's asking you where is your data. So it says list, and that should be L1 because we put it in the first list. Frequency, just make sure that says 1. You don't need anything else there. And then C level, that's our confidence level. What confidence level did we want?
95.
95, so 0.95. And calculate. And let's see how close it was. We got 35.246 and 38.354. We were more accurate than the calculator. All right. I think I said interpret on this question. So it means 95% confident. The true mean, or the population mean, is between these values. Any questions there? Let's try another one, just solely on our calculator, make sure we can. So I want the 99% confidence interval about the population mean for pennies minted after 1982. So first, I gave you the data again, we have to put it in. So I get 2.4516 and 2.4767. So what you guys got? And I didn't even ask you to interpret it, so that's it. I'm 99% confident the true mean is between these values. Just real quick, because I didn't do one like this, if you go back into stat calc number 8, or sorry, stat test number 8, if you flip it over to stats, I just want to show you what you would have to put in. You would have to type in your X bar, your sample mean, your standard deviation, and your N. So that would be if the problem didn't give you all the points, it just told you in the problem the mean is this, standard deviation is this, then you would type those in.
It literally has everything already.
Yeah, if you've entered everything in L1, it carried it over for you automatically. But, last thing I want to talk about is where we ended yesterday. If you are trying to decide how big does your sample need to be to reach a certain level of accuracy, there is a formula for that. It's on the formula sheet. The second bullet under sample size says to estimate the population mean. We have this formula. It goes back to Z's, very similar to the p-hat formula we were using yesterday. There's a big explanation why it doesn't really matter. We have a formula, we just need to make sure we can plug in to a formula. Okay, this would tell us how many people we would need in our sample. And again, like we talked about yesterday, since it is people, you always round up. Okay, so if I go back to my forward focus problem, I want to know how large of a sample is required to estimate the mean miles per gallon within 0.5 miles per gallon, so that is my error. with 95% confidence. Okay, so if I'm looking at my formula to figure out the things we need, it tells me n is the z alpha over 2 times s divided by e squared. I didn't give you s in the problem, but we used this in example, what was it? Example 4 maybe?
2917.
So that standard deviation we had in example 4. Alright, the z alpha over 2. So let's practice that again from yesterday. That means we have 95% in the middle. So you have 5% left for the ends. So each one will get 2.5. Okay, it's a z, so we're back to our normal table. We are looking for the z. So if we think about how the normal table reads, it gives us area to the left. So the total area to the left is 0.975. So I'm looking inside the table. The closest I can get to 0.975. Oh, it's on there exactly. And the z that matches that is 1.96. Because this table
Oh,
gives
really?
us the area less than.
Plus.
Yes, the 2.5% on that tail. Is everyone okay with where I got that? Okay. So we're on the z table or the normal table because
yeah.
it's a z on this one.
Oh.
And then so our total area to the left of this is the 95 and that 2.5%, so it's 97.5. So we're looking for 0.975. And so the z that matches that is the one that So then if we plug into our formula, so 1.96 times 2.1 or 9171 over 0.5 squared. And I got 130.75996. So we would have to have 131. It is important to write down what your numbers are. For instance, if you had rounded your standard deviation to like 2 decimal places, you would have gotten 132 instead of 131. So just make sure I can tell what you're plugging in. Any questions on that? So, I'm done. I want you guys to work on your homework. And